Hello everyone, welcome to IB Math Solution. Today we'll be learning about Venn diagram regions. So when we have a Venn diagram of set A and set B, it looks like this diagram. It has four regions. Region 1 is this, where we have only A, nothing else. This is the second region, which has A and B both. Then we have third region, which has only B, not A, this part. Then we have the remaining part, which is neither A nor B. So we can write it in this form. So, and the whole thing is the universal set U. Therefore, we can say this part, the first part, A intersection B prime, we can call it A but not B. The second part, A intersection B, it is the part where A and B both are present. Therefore, this part is A and B both. Then the third part is where only B is present. Therefore, we can say B but not A. So we can write it like A prime intersection B, or we can also write it like B intersection A prime. They both mean the same thing. This one and this one, they both mean the same thing. Then we have this A prime intersection B prime. This is this region, and this is called the region where neither A nor B is present. Let's talk about this part. This is the region where either A or B is present. So what did we learn about unions? A union B was this part. This whole part was A union B, and this part contains either A or B or both. Therefore, we can call it A or B. Now, we will have certain number of elements in each region. How can we represent those number of elements? So this is the diagram. When we write a number in parentheses, we mean that this number is the number of elements in this region, A but not B. Therefore, we can say the number of elements in A but not B is equal to 7. From here, the number of elements in A intersection B, that is A and B both. So this is the area where A and B both are present. Therefore, A intersection B, the number of elements in A intersection B is 3. Now, the number of elements in B but not A is equal to 11 from here. So this is the part. This is the region. And the number of elements in A prime intersection B prime, that is neither A nor B, that is 4. Now let's move on to exercise 2G and solve some questions. So question number 1 says, use the Venn diagram to find the number of elements in B. We know B is this whole circle. Therefore, the number of elements in B is going to be 2 plus 5, that is 7. The number of elements in A prime, this is going to be everything but A. We know A is this part, this whole circle. So everything out of this circle will be 5 plus 9. A union B. We know A union B is this part, and everything inside this part is 7 plus 2 plus 5, that is 14. A but not B. So the number of elements in A but not B is going to be A minus the part where B is present. Therefore, 7. B but not A. So B but not A is this part. B but not A. The number of elements is 5. Neither A nor B. The number of elements in neither A nor B is this part. Let's move on to the next question. This is a similar question to the previous one. Therefore, this whole question is your homework. Let's move on to the next question. Use the Venn diagram to find the number of elements in B. The number of elements in B is going to be B plus C. The number of elements in A prime will be C plus D. The number of elements in A intersection B is going to be small b. The number of elements in A union B is going to be A plus B plus C. The number of elements in A intersection B whole complement is going to be, first we need to know what is A intersection B. A intersection B is this part, and its complement will be everything apart from this part. That is going to be A plus C plus D. The number of elements in complement of A union B. The number of elements in the complement of A union B. First, what is A union B? A union B is this whole part. This whole region is A union B. And everything apart from this region is only this part. Therefore, this is going to be D. Let's move on to the next question. Question number 4. Use the Venn diagram to find number of elements in P intersection Q. So P intersection Q is A. The number of elements in P, the number of elements in P will be 2A plus A. That is going to be 3A. The number of elements in Q is going to be A plus A plus 4. A plus A plus 4. That is going to be 2A plus 4. The number of elements in P in union Q. P union Q. That is 2A plus A plus A plus 4. 2A plus A plus A plus 4. So this is going to be 2 plus 1 is 3 plus 1 4. 4A plus 4, or taking 4 common from both the terms, number of terms in Q prime. We know Q is this region and Q prime will be everything apart from this region. Therefore, 2A plus A minus 5. 2A plus A minus 5. This is going to be 3A minus 5. Number of elements in U. Number of elements in U, the universal set. Universal set contains everything. Therefore, sum of every region will be the universal set. 2a plus a plus 5, sorry, a plus 4 plus a minus 5. So this is going to be 2a plus a is equal to 3a plus a is equal to 4a plus a is equal to 5a. Now 4 minus 5, that is going to be minus 1. So this is our answer. Section B. Find the value of a if number of elements in the universal set is 29. So we know the number of elements in universal set is 29, and from the formula above, number of elements in the universal set is 5a minus 1. This is going to be equal to 29, hence 5a is equal to 29 plus 1, and a is equal to 30 divided by 5, that is going to be 6. Number of elements in the universal set is 31. So if the number of elements in the universal set is 31, so from this formula we can again write 5a minus 1 is equal to 31, and 5a is going to be 32, and a is going to be 32 divided by 5, that is going to be 6.4. Now this answer is not acceptable. Why? When we talk about the number of something, the count of something, the count of something can never be in decimal form. It has to be a natural number. When we say there are 6.4 people in this gathering, is it possible? No. So decimal numbers are not possible when we are talking about count of something. Therefore, either 6 is possible or 7 is possible. There cannot be a 0.4 count of something. Therefore, 6.4 cannot be a count of anything, as we know there can never be 6.4 people or 5.9 apples. Let's move on to the next question. Use the Venn diagram to show that the number of terms in A union B is equal to the number of terms in A plus number of terms in B minus number of terms in A intersection B. So let's first take the number of elements in A union B. So from the Venn diagram, we can say the number of elements in A union B is going to be A plus B plus C. Now, the number of elements in A is A plus B. The number of elements in B is B plus C. And the number of elements in A intersection B is B. From these three equations, if we write the number of elements in A plus the number of elements in B minus the number of elements in A intersection B, this is going to be A plus B plus B plus C minus B. Now this B will cancel this B out and we will be left with A plus B plus C. Hence we can say this term over here and this term are exactly same. Hence this term over here will be equal to this term over here. Number of elements in A union B is going to be equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Hence shown. Section B. The number of elements in A intersection B prime, that is number of elements in A but not B, is equal to number of elements in A minus number of elements in A intersection B. So if we calculate these terms individually, we know number of elements in A but not B will be A, small a. The number of elements in A will be A plus B, and the number of elements in A intersection B is going to be B. We can cancel this B with this B out, and hence A is going to be equal to A. Therefore, the left hand side is equal to the right hand side. Hence shown. Let's move on to the next question. Now the question says A and B are disjoint sets. So this is A, this is B, and they don't overlap each other. This is what disjoint sets mean. And this is universal set. Now we know the number of elements in A union B is number of elements in A plus number of elements in B minus number of elements in A intersection B. This is a formula. And from this Venn diagram, can we say that the number of elements in A intersection B is 0 because they do not overlap each other. Hence, the number of elements in A union B is equal to the number of elements in A plus the number of elements in B. Hence shown. Let's move on to the next question. Given that the number of elements in the universal set is 26, the number of elements in A is 11, the number of elements in B is 12, and the number of elements in A intersection B is 8. Find the number of elements in A union B. We know the number of elements in A union B is number of elements in A plus number of elements in B minus number of elements in A intersection B. So by just putting the values, this is 11, this is 12, and this is 8, we get 15. That is our answer. The number of elements in B but not A. So for this, we need to draw a Venn diagram. So let's draw a Venn diagram. This is the universal set. This is set A. This is set B. Now we know that A intersection B is 8. When we write the number of elements in the Venn diagram, we start from the intersection part. So A intersection B comes out to be 8 elements. Therefore, we'll write 8 here. Now, number of elements in A is 11. Now we know A is this whole part. A is this whole region. In this region, 8 elements we have already written. And there are total of 11 elements. Therefore, 3 are remaining. So those 3 elements will go here. Similarly, the number of elements in B is 12. This whole part, this whole region contains 12 elements. Out of those 12, we have already written 8. So only 4 are remaining. And we know the total number of elements in the universal set is 26. So this whole universal set contains 26 elements, and out of those 26 we have already written 8 plus 4, that is 12, plus 3, that is 15. So 15 elements we have already written and 11 are remaining. Therefore, this region will be 11 elements. Now the question is asking the number of elements in B but not A. So that will be 4. This is our answer. Let's move on to the next question. Now, while writing the number of elements in the Venn diagram, we start with the intersection term. So the number of elements in M intersection N is 5. So the number of elements in M will be 13 minus 5. That is 8. And the number of elements in this region will be now we know the number of elements in M union N is the number of elements in M plus the number of elements in N minus the number of elements in M intersection N. By putting the values, this is going to be 26, this is going to be 13, this we do not know, and this is going to be 5. From here we can say 26 minus 13 plus 5 is going to be the number of elements in N, and the number of elements in N will be 26 minus 13 will be 13, and 13 plus 5 is going to be 18. Therefore, we can say the number of elements in N in this region is 18, out of which 5 we have already written. Therefore, this region will be 13. And we know the number of elements in the universal set is 32. 32 is this whole part. So the remaining part, that is neither M nor N, will be 32 minus the number of elements in M union N. M union N is 26. So 32 minus 26 is going to be 6. And those 6 elements will be here. Now the question is asking us find the number of elements in N. So we have done this part already. And find the number of elements in the complement of M union N. We know M union N is this part, and its complement will be everything out of this region, that is 6. This is our answer. Let's move on to the next question. So the question says the number of elements in R intersection S. We have to find this. We know number of elements in R union S is equal to the number of elements in R plus the number of elements in S minus the number of elements in R intersection S. By just substituting the values, this is 48, this is 25, this is 30 minus the number of elements in R intersection S. So number of elements in R intersection S is going to be 25 plus 30 minus 48. This is going to be 7. Now we can substitute the values in the Venn diagram and calculate the values. Now we can put the values in the Venn diagram. So R intersection S is going to be 7 elements in this region. Number of elements in S is 30. So S but not R is going to be 23. Number of elements in R is 25. Therefore, R but not S is going to be 25 minus 7. That is going to be 18. And we know the number of elements in R union S is 48 and universal set is 50. Therefore, the remaining 2 elements will go over here. Part B says the number of elements in S but not R. S but not R is going to be 23. That's it for this exercise. I'll see you in the next session.